What we are going to talk now is about the building of the integrated documents, which is a mix of SQL and NoSQL. And this is Microsoft's point of view of the dual personality in the new SQL 2016. So this is part 1 of 4. So my name is Luis Leal and I'll be your presenter. So you can download any of the presented material, including the backup for the database. If you want to skip the building, you can go straight to the backup. However, I recommend to follow the steps for the construction. Here we go. So we are going to do the design and building of an integrated document system using Microsoft SQL 2016, as I mentioned, in a mixed environment between SQL and NoSQL methodologies. Let's start to define documents. From IBM, we have from the Field Guide to the World of Modern Data Stores, they come with a definition of what is document. And basically, as it mentioned here, document might not be a document the way that we consider, but mostly any key, any information that we have in the computer digitized. And then we have some kind of a name or a way to recognize that exists, and then we can build on that. That's going to be the definition of document. And this guide is very useful. You can find it here. Here's the guide we're going to so it mentioned the evolution according to IBM between or from or parallel to the SQL and the non-SQL. Okay, and according to them, the non-SQL facilitates more the use of big data. So we are going to refresh the concept of what is a relational database, and this is basically from the Wikipedia. For all of you that are using everyday SQL, you know what is an SQL, you know what is a relational database, and then you know how to use it. In contrast with the NoSQL, some authors say non-SQL, some other people refer not only SQL. Probably this is kind of not only SQL. And this is one of the differences that they establish here. This is a tabular way of store documents and this non-tabular way of store documents. We are going to see what's a JSON column that allows you to create a schema in a different way. For the design of this database, we are going to create a structure containing documents inside an SQL database. We're going to use file tables where we are going to define what's a file table or explain what it is in a little bit. We're going to use full text indexing. By the way, full text indexing and file tables are not new in the 2016 version. Probably they exist in 2 versions ago, but now they are more refined and then added other features that we are going to inspect in the next 2 or 3 slides. We're going to include a Microsoft Semantic database exactly for that, to extract the information and the concepts inside of the documents. We're going to create a custom metadata. And why is this important? Because half is the information contained in the document, and the other thing is how we classify and view and do hierarchy queries or hierarchy structures of the concepts and the documents. We're going to search or to query by the content in document, including words, phrases, and the semantic, and of course the metadata. And we are going to create or attempt to create dynamic hierarchy in a way that we can extract knowledge from multi-perspectives. We are going to attempt to create SQL and NoSQL on the same database, and we are going. This is the intent, is to create eventually intelligent databases databases that you can, in a natural language, inquire, and the database will accommodate and create answer and find the constraints according to the business rules implemented to accommodate the queries that you are doing. And then we are going to use this platform to apply some intelligent systems, business intelligence software, such as Power BI in this case. So we are considering 3 databases: IBM DB2, Oracle databases, or database including MySQL, and Microsoft SQL Server 2016. First, we are going to create the SQL. Then we are going to do add semantics, and then we are going to take a file structure containing this kind of documents, PDF, Word, emails, etc. And we are going to move that inside the SQL. Then we are going to add full index text for our database. Then we are going to add metadata, customized metadata, and then we are NoSQL concepts inside. We take this whole thing and see what happened. And that's what we are going to build today. So for the database, we could have used IBM, Oracle, or SQL. We are going to stay with the SQL 2016 server. For that, we are going to see some of the features that are on this version. So SQL Server has many new features, and some of them are enhanced features of what it was. We are going to see some of those features, at least those that are very important for this project. We are going to see, you can go to the web page on Microsoft SQL Server. Actually, this is seed and the net, and they're having some good description of what is the interesting part. Again, you can see that this made or attempted to answer the questions about big data, NoSQL, etc. One of the advanced analytics, and we're going to see some of those. So let's go and see. One of the interesting features is that it's always encrypted, and that's very important because now we are handling information from clients, including social security, addresses, date of birth, and other confidential data that we want to protect. So, but that's important for the general application. It's very important for all the applications. So it's an interesting feature. This is a randomized encryption key that allows you to do some encryption. But one of the things is that, let's start with some information that is interesting here. Dynamic data masking. So, like there is some information that you want to mask. So basically, this is a business rule applied from the database. And then, for instance, in this case, they have the credit card number, and they put a mask for only the last four of the card number will be displayed. So this is a business rule embedded in the database. And then here, here's another one that is very interesting. Row level security, according to the login, will help restrict or grant access to records. And that's going to be interesting because in the document integration of documents, there's some documents that are only for the eyes of some upper management or confidential people, etc. So in this case, they have these 4 users who are allowed to have security level 1 and access the records. JSON support. JSON support is a key feature added in this version that will allow us to create columns that will have a JSON schema. So the part of, or a great part of this project is based on the JSON support now. We transform columns into JSON column, give the schema, and the schema is very arbitrary. We can define the schema any way we want. So in this case, it's just a query using JSON. We are going to illustrate, actually to utilize and present some JSON columns. R comes to SQL Server. R is a very important concept on the understanding and putting logic or statistics. We can, in the past, we need to take the information, apply our scripts, put it back into the database as a new table. Now it's integrated. And then this is one script. We're going to see some of the scripts for that include R for extraction of concepts and content of the documents. Stretch database. This is also interesting. Basically, the new one of the features that you can have divide this into parts. Whatever is on the premises, and the other will be on the cloud. And one of the things is that whatever you access every day can be on your premises for speed, whatever, protection. And other part of the database will be on the cloud. In this case, it's Microsoft. They say, yeah, sure, it can be in the Amazon, can be in any cloud. And this is how it's presented. This is the not everyday use of data, and this is every, so similar. Temporal table. That's another important feature that we are going to use for this project. Why? Because if we want to insert or manage the metadata to be following all the time the document, then we need to access the insert, the new insert, the deleted, and the change. So this table provides, among other things, a short-term access to the operations that we have done in the table. We can create more efficient auditing technology. We might audit in a kind of more organized way the tables. So we are going to see some, in this case, it's a query from the beginning to the dates of the changes, and that's a very interesting thing. We will present a couple more like deleted and inserted, updated, and temporary table according to the records. Polybase. Polybase is another part of the movement for the new SQL implementation. So Polybase allows you to have a head up. By the way, head up is open source. Is like everything is hardware independent. It's kind of semi-structured. You might have structure, and in order for this to work, you have you can select the feature and the implementation, or you can add later. So for this project, we are not using the header too much, but for the next projects is important part. Microsoft SQL has a file table, but what it is a file table? So a file table is a table that can contain documents. So this gives you a predefined schema. It's already it's no change. So and allows you to do file streams. And let's see if we go here to the IBM. And sometimes this page takes a bit to render. Okay, here we are. Here is the explanation of, or supposed to be, if it's coming. Okay, here we are. File table. And the benefit of the file tables. So it's a non-transactional streaming access, hierarchical representation, very suitable for documents. In fact, it's made for documents. And in the definition of what is a file table, I just took it from here. There's some consideration and when to use file tables. Well, this is about file table. What's metadata? According to the Wikipedia, which is not the best sources, but it's a very common source, metadata is information about information, and it's the two kind of metadata exists: the structural metadata and descriptive metadata. So, and we are going to create, and you can create more than one set of metadata for a document. You can have different perspective. You have metadata from, say, educational point of view or health point of view on the same set of documents. In this case, we are going to have a very simplistic metadata. We are going to have an author, date, etc. However, this is based for an presentation, because author in production, author cannot be, a document can have more than one author. So what we do is transform this author into a JSON column and then provide the schema and add as many authors for the document. We can do the same thing for subject and project and language. And the specific semantic is just for an experiment that I'm doing. So probably, anyway, the abstract is just a small summary that is going to be also queried by, or included in the queries. So custom metadata is the metadata that you or your organization need or want or define or decide to identify and classify documents. What's semantics? The semantic, I'm talking about the semantic database. We already defined in what is semantic analysis. This is semantic database, and we are going to go to the website. And this is to download the semantic database statistics. Sorry, this is where you can download the semantic. Basically, you can do semantic search into an structured document stored in an SQL Server database. We can extract an index, and this is like score, or how the document can be matching the semantic that you want. Semantic and words might be not exactly the same thing. We can query the document files for words or phrases, but for semantic it's a bit different. So we're going to see that. So basically we are going to use the semantic database. This is, in this case, is something that is going to be working in the background. We install it and let it do its job. We don't have to do anything. We don't have to query against the semantic database. We just install it and let it go. And this is the presentation of the first part. So thank you, and I'll see you in the next